Hello everyone. Now the problem today we are going to solve is Leetcode medium level problem of the binary tree. So what is said that we have been given a root of a binary tree and integer limit, and we have to delete all the insufficient nodes from the tree simultaneously, means all at once, and return the resulting binary tree. So what is an insufficient node? A node is insufficient if every root leaf path intersecting the node has a sum strictly less than limit. Means ki suppose this is a node, and if every path that is arriving from this node, there are two paths. So all these paths, it is sum, and if in all the paths that sum of the leaf, leaf node, sum of the distance of the leaf node like 1 plus 2 minus 99 is less than the limit in all the paths. So then it is called insufficient node, and then we have to erase it. But it is simultaneously, so this means that at once we will check all the insufficient nodes and we will erase all them once. It is not that the tree gets updated every time we erase a node. So it is all at once. Basically, we need to check if any of a single path from root to leaf that is passing through this node has a value greater than limit, then this will exist. So let us see like this. See, limit is 1. So 1 plus 2 plus 4 plus 8 is greater than 1. So 1 is safe, 2 is safe, 4 is safe, 8 is safe. 1 to 4 8 is already safe. Now 1 to 4 9 it is also safe. 9 is also safe. 1 to minus 99 minus 9 it is decreasing the sum and it is greater less than limit. So it will be erased. It will be erased. Since both are erased, so this will also be erased. So minus 99 is gonna be not no node is passing till the leaf with a sum greater than limit. So now 13740 sum is greater than limit. 137 minus 99 cannot be answer. So that is why minus 99 is erased, and 1 3 minus 99 this also needs to be erased because this pass also sum is less than limit. So let me tell you the approach and that I have used, and I will be telling you the explaining you the code, Python code. So basically, see what I have done is I have run a DFS, and what is passing to a node? We are passing a sum of the uh, some of the nodes, the value of nodes from the root node to that node. So basically, what we are doing for a particular node in a DFS, in my approach, I have passed a value which is the sum of nodes from root to that particular node. Now I am running DFS to the left side or to the right side, and I am calculating the left sum and right sum. And now what we are doing is that we are adding this value plus left value plus the value of the node, and if we are checking which is the maximum. We are taking the maximum one, like left and right. Maximum one should cross the value of limit, so we are adding right plus value plus the node value, and if it is greater than limit, so then it is a safe node, and we can skip it. Otherwise, we need to erase it. And in every time we run a DFS, suppose we want to erase it, so we basically to erase it, we make it null. That is the rule, because if it is a null, then all the subsiding, all the children of the nodes will also be null. Remember that. Why? Because there is no path. It means that there is no node through which the sum has been achieved. So all the children will also be null. So basically, in every time I am returning the node what is possible along with the value of the maximum sum. Like every time my function returns node. What should be node? It should be null or it should be the particular node. That should be the child. Other than that, I am also returning the sum, maximum sum. Like maximum is left or right, whatever is maximum plus node value. So that is the sum till here so that I am passing so that it can calculate the left child and right child sum. So let me tell you show you the approach I have used. See. So basically here I have used a DFS. I have root, value, and limit. Value is the sum from root to that particular node, and limit is a limit that have been provided to us in the question. So if it is not root, then it is returned no null means none, and minus 10 to the power 14 value so that it can exceed the limit. And this sum will never be considered for the crossing the limit. That is why I have put such a large value. If it is a leaf node, suppose if not root dot left and not root dot right, it means it is a leaf node. And if it is a leaf node, we are checking if the value is less than the limit. Value plus sum means the sum from top root to that node leaf plus sum of that leaf is less than limit, then we are returning null because it needs to be erased. Then none and root dot val. Root dot val is the value of that particular node. But if suppose it is greater than limit, then I am returning root. Basically, this child should exist. So root and root dot value. Now what we are doing in each DFS, we are returning a tuple. So in the left child is the basically we are running a DFS to root dot left with a value from the root to the particular node will be value plus some of this particular node which is there and limit which is same. So again we are running DFS for both left and right, and we are taking the left child, left score, and right score that was there. Now root dot left is left child and root dot right is right child. We are taking the maximum of score, which is left score plus root dot val and right score plus root dot val, and if child plus value from the top is less than limit, then this needs to be there, so we are returning null and sum of the maximum sum basically for that children. Otherwise, we are returning the root because that should exist. And we are running if not root return none if it is root exist. So DFS of root with the initial sum from the root is 0 and limit, and we are returning T0, that is the node, the children. So like that.